Yeah.
So we need to have a task, a specific task that we as engineers design, and we ask the machine learning algorithm to fulfill this task. And then we go to understand what type of impact, and then, it's like we opening the Pandora box.
Yeah.
From research point of view, that's very good because we always have a job.
So if you open the Pandora box, you're not frustrated? Or
personally, no. I love it.
Okay.
Personally, I love it. Yes.
This is Coffee with Martin. In this episode we explore a shift that is already happening, but often goes unnoticed. What if an aircraft doesn't just fly, but continuously understand what's happening to it? Not after the fact, but in real time. I'm joined today by Dimitrios Zarouchas. He's an Associate Professor and Director of Center of Excellence in AI for Structures, Prognostics and Health Management. Today accompanied by Roger Groves. He is also an Associate Professor and leads the research groups in non-destructive testing and structural health monitoring. Together we talk about sensors, data and predictive maintenance, and how aircraft are evolving from static machines into machines that can monitor, understand the data and anticipate on it. Because the real question isn't just how we build aircraft, but how they start to understand themselves. Let's get into the conversation. Welcome, both of you, Roger, Dimitrios. So my first question to enter this podcast is, what type of coffee do you drink?
Black coffee.
Black coffee?
Black coffee. No sugar, no milk. Otherwise, it's not coffee.
And you're Greek, right?
I have to be 100% honest. The Greek coffee is a Turkish coffee. But as Greeks, we call it Greek coffee. I don't really like it. I'm more towards the Italian espresso kind of, or Americano.
And what's the difference between, let's say, Italian coffee and Greek, Turkish coffee?
I think the way that they roast the beans, I think, but I'm not very...
Yeah.
I like to drink. I don't know how to make it, or the process behind.
And do you drink a lot of coffee?
Yes.
Yeah?
Yeah. 5 to 6 cups. So this is already, so for the people that are listening, we are 11 o'clock, something like that.
Yeah.
This is already my 4th.
Okay. Yeah. And then do you stop drink coffee at a certain point in the day?
Yeah, till last night I had at 10.
Okay.
Yeah, I drink a lot. So for me, it's my drink. So I'm really happy that I'm here. Yes.
Yeah.
With this time.
And for you, Roger, as a Brit?
Yeah, I'm more for drinking the tea. But when I'm at work, coffee's a normal drink to keep me sharp. And when I'm at home, then I'm grinding the beans and then making the coffee with the machine at home.
Oh, nice. And if you drink tea, is it with milk then?
Not anymore.
No.
No.
That's stereotyping Brits, right?
Drinking tea. It's English breakfast tea, but not with milk anymore.
Okay, thanks. My second question is, can you introduce yourself in one full sentence, Roger?
Yeah. So I'm Roger Groves. I'm Associate Professor in the Faculty of Aerospace Engineering at TU Delft. My research topics are non-destructive testing and structural health monitoring. I'm particularly interested in the sensor technology and measurement aspects.
Okay, thanks. And you, Dimitrios?
Dimitrios Zarouchas, a very Greek name. I'm also associate professor, colleague of Roger in the same department, the same faculty. My background is on mechanics of polymer composites, so structures that we build, lightweight structures. I did my PhD on structural health monitoring techniques. In the last 10 years, I work in the trinity of physics models, structural health monitoring, and of course AI, machine learning mainly.
And if you want to compare the two fields, where do you connect?
Almost everywhere, I think.
Yeah, well, we certainly connect on the structural health monitoring topic. I think we come a little bit from different sides. I come more from a physics side.
Can you maybe explain what structural health monitoring is for the listener?
Yeah, this will be interesting to see the different definitions. So structural health monitoring is where you're integrating sensors, maybe actuators into a structure, and you're using the data that comes from those sensors to do diagnostics of the structure, to do load monitoring of the structure, and collecting data also for prognostics.
And is it especially in an aircraft or also different structures?
Yeah, it's across all structures which are under a high load. But
Yep.
my research is mostly focused on aerospace.
Yeah.
I would say also wind energy, but the same principles can be used for other structures which carry high loads.
Yeah. And for you, structural health monitoring?
Actually, Roger is covered it quite well. The only thing that I would add is that the sensors that they are on structure should be permanently installed.
And is it installed after you make the structure, or is it incorporated in the production of the structure?
It could be both.
Okay.
It could be both.
Yeah.
But talking about in our field, that's mainly on aviation, or civil aviation, is after the manufacturing.
Yeah.
So they install. So meaning that most of them, they are attached to the surface of the structure.
And if you would compare, let's say, aviation, general aviation, 1970s, right, compared to today in structural health monitoring, what's the big difference? Or can you sketch what we did in the past and how we do it now?
Well, there is no big difference because things haven't changed. So the commercial aviation, civil aviation, still is trying to identify the business behind it to use structural health monitoring. And this is where our research contributes on that, because it's not about only monitoring the current state of the structure, so if there is damage, where the damage is and what we can do that, because with current regulations, if damage is found, needs to be fixed. That's why they have the schedule-based maintenance. So this SHM, the structural health monitoring, is a part of a bigger picture, which is about maintenance. Of this, because we need to keep the aircraft able to fly safely.
Yeah, but in the last 50 years it did not change because it's a regulated, heavy industry.
Yeah. Yes.
Is that going to change, or
we hope so?
Roger, can you elaborate?
Yeah, so regulations are really one of the things which is slowing down the implementation of structural health monitoring in the civil aviation. We would think that perhaps we have to look for specific cases where we can push through with the structural health monitoring and get them more widely adopted in the industry.
And can you give an example of what's already technical feasible, but we are not applying in the current airline aviation?
Yeah,
sector?
I mean, from the sensors point of view, lots of things are technically feasible. We've got strain sensors, vibration sensors. We've got fiber optic sensors which can measure temperature and strain, and also some further parameters. I think one of the things which is holding us back at the moment is that we are looking at retrofitting of sensors very often. So this is a sort of an inconvenience to already have the structure and then integrate the sensors. So I think one of the ways that we should be looking in the future is to go to more towards design for structural health monitoring, design for non-destructive inspection also. So that at the stage where the aircraft is being designed, the inspection and monitoring capability is already integrated at that point.
Sticking a sensor on the current airframe is difficult because of the regulations.
Yes. And it is happening. So there are examples, especially overseas in Delta Airlines, for instance. They do. They are using piezoelectric elements, so they are using the guided wave principles on it. But as Roger said, they are used for specific cases where, for instance, the inspection is extremely difficult. Inspection means someone goes there. So they use it for such a reason, but not for maintenance credit. So they are using it in order to be able to collect data to see if it makes sense for them to ask FAA, for instance, to get approval for maintenance credit.
Yeah, to learn from, or
yes,
to get trust in the future that they are going to apply this technology.
Yeah. And to have a lot of proof, Martin, to go to the regulators and to provide evidence that it works. And as long as it works, then the FAA, the regulators can release a way to do.
Like the FAA is the regulatory body?
In States, in the United States.
Yes. And here in Europe?
EASA.
Yes. Maybe a question before. What is the definition of a damage?
Yeah, this is a very good question.
Difficult questions.
Yeah, we can think about whether we have a damage is defined as something that we can detect as a deviation in the structure. But we could also think that maybe it's a damage that we can't see yet. There's different definitions. I would say it's something which is causing a weakness to the structure.
Yeah, that affects
that changes the initial properties.
Okay, if you say the old school is based on, let's say, material science, and now we're adding sensors to learn more from the structure. What is the downside of let's say trusting sensors, or is there no downside from?
Yeah, it's a case of calibration. So we've been using non-destructive testing techniques for a very long time now. We can think back to the railways, even to the steam engines, where they would do a tap testing on different parts of the wheel, and then listen to the sound to see if there's any deviation in the sound from a damaged or undamaged wheel.
Yeah.
As these technologies got non-destructive testing technologies got developed, then more and more calibration came in, procedures, and then these procedures have been clearly written down. They get certified to find particular types or particular sizes of damage. And then for the structural health monitoring, it's just an extension of this process. It's not a easy extension, but it's extension of this process to do the proper calibration. So we're sure of what we're measuring.
And you mentioned NDT, non-destructive testing, and then on the opposite there's destructive testing. Can you place both methods in a frame? Where do we use one another? Or why not?
The destructive testing comes usually with the certifying a specific design. And so in aviation, the building block approach is very well known and very well used for many, many decades now, where we are trying to characterize the material that we're going to use. So we need the mechanical properties, elastic and mechanical properties. And building on that, we go to a more specific designs up to the full scale. And for instance, for the full scale, they need to do tests in order to break. And this is destructive testing, which is extremely expensive, time-consuming. Yeah, that's the thing that we do during the certification process. And the non-destructive is all the techniques that we are using in order to identify, to measure properties of the structure of interest, either during the certification process or when it is already in operation.
And is if you talk about aircraft, the maintenance business, is that a big business?
Yes.
Yeah?
Yes. Okay. I think it counts Exactly nowadays I cannot say because of the price of the oil, because it has increased a lot, but the maintenance can account up to 20 to 30% of the expenses of an airliner.
That's a lot.
That's a lot.
Yeah,
that's a lot.
So if we can let's say save there, or if we can prove it to the airlines, then the business case will be
yes.
Yeah.
I was just going to say that the simple way to explain the non-destructive testing is this is parts that we would like to use again. So if it's a part that's being tested before going on the aircraft, then we use non-destructive testing so that we're not damaging the part. So that's the main distinction.
Yeah. And at the TU Delft we do projects. Let's say, how do you build that experiment in a project? So you have an idea, like a research idea, and you think maybe this is the new way of solving the problem. How does it work? Such a project or such an idea or such an experiment?
Depends really the project. Yep. What we are targeting, because we may targeting for a technical solution where we are going to prove either if a sensor works or what's come after the sensor, the data that we are collecting, if we can detect how big the detection and all these things. But there can be also project that we want to take this technological solution and increase a bit the TRL. The TRL is the technical readiness level, and try to make towards a product that can be used. So it depends on where we are targeting the different.
So how comes the research idea further? So I'm thinking, if you bike home, right? You have this idea. I want to research this, and then what's the next step?
So what's in a big European project that ran between 2018 to 2023, so it was a 5 years project that actually TU Delft led. So it was a European project under the Horizon 2020 program.
Mm-hmm.
We were actually advancing the concept of structural health monitoring to structural health management. So meaning that also we do prognostics and we manage the health of the structure in order to decide when it's the best time to go for maintenance. And this also we included planning. Logistics came into it. So for instance, and one of the biggest partners was KLM. And we worked closely with them, and they have products there that they are like software Prognos, and they managed to adapt few of the developments that we had in this project to their service.
Nice.
So that's an example. So we changed the monitoring to a bit of management there.
Yeah. For me, the project ideas, they get developed in two different ways. So one is you have the creative idea, and then you look for a project where you can extend that idea, extend that technology. So for me, it's quite often to do with sensors, trying to measure things which can't be measured with conventional or commercially available sensors. So so we have ideas. We're more into the physics, more into the optics, and more into the ultrasonic wave propagation at this stage. So we like to sort of try out ideas and find a direction, find new directions and new sensor technologies. And then in some projects we take a different role, that we have more of we are solving a problem. These are also very interesting projects where partners in the project want to measure something which can't currently be measured, and then you have to, at the beginning of the project where you're writing the proposal, have to manage the risks and say what's the possibility that we can make sensors or technology that can solve that problem.
So often the whole line of business is involved in such a project, let's say the airline or a sensor producer.
Yeah.
What was the last time that the outcome of such a project, let's say, surprised you both?
Well, every day. Every day we have surprises in a good and not in a good way. In a not good way, it always motivates, at least personally. Because it gives me the motivation to continue and try to find out why it didn't work, for instance, as we thought it, because it may have worked in a different way that we were supposed to.
Yeah.
An example is, again, for our background, because nowadays we are using a lot of polymer composites.
Yeah.
Especially in aviation, is carbon fiber, reinforced polymers. The lack of a unified physics model that gives us the degradation gives us always surprises when we go to the lab and try to understand how, by changing as something that we consider that it will not have an impact, it does have an impact.
Yeah.
And then we go to understand what type of impact, and then, it's like we opening the Pandora box.
Yeah.
From research point of view, that's very good, because we always have a job.
So if you open the Pandora box, you're not frustrated? Or
personally, no. I love it.
Okay.
Personally, I love it. Yes.
Yeah. And then, and for you, Roger, how do you?
Yeah. So for me, I would say that the projects working with the energy transition, particularly towards hydrogen for aviation, that's been a maybe more challenging than I expected, and also very much more emphasis on that. There's lots of projects running. We're active in a number of the European projects, and it seems that the conventional non-destructive testing, structural health monitoring solutions are not working for these hydrogen, particularly hydrogen storage tanks, and this is due to they're working at very low temperatures at 20 Kelvin. There's a difficult environment to work with the sensors. For example, it needs to be like a spark-free sensors, so that we don't ignite the hydrogen. So I would say that that's perhaps a little bit of a surprise for me that transition was not so easy, but it's also been a push to develop lots of new technology. And we've been working particularly on we've been working with a fiber optic sensing technology for temperature and strain measurement. We've been working on technology for hydrogen sensing, so detecting leaking of hydrogen.
So in the beginning of the project, you had an idea, and then along the way you figure out maybe this is not the solution, or maybe a dead end. And then how do you, let's say, turn, or how do you pivot in that?
Yes, you have to build it on a firm foundation, I would say.
Okay.
So that you have the knowledge that you gain from the previous projects, that gets you already to a certain level. Probably, I would say, from my point of view, it gets us already up to the sort of the close to the state of the art level, or the state of the art level, and then we look in these projects to build on the state of the art, to go beyond state of the art.
But if you find something that doesn't work, and if you bike home, right, are you then frustrated, or are more excited for the next day to?
I'm more excited to try to find new solutions. I like the challenge, and I like to think about these problems in detail. I like to discuss them with the other researchers and also researchers in my team. And I also like to try things in the lab that maybe we're not sure if they're going to work or not. But if they never work the first time, but then you can tune them a little bit, and then at some point we hopefully will get something which is working and solving the problem, and producing something new, so something which doesn't exist. This is very exciting for me.
Is that the reason why you're both in academia? Is this, or maybe
one of the reasons?
Yeah,
one of the reasons. Yes.
Can we do this way of working also in industry, or is it not possible, you think?
Depends the industry.
Yeah, so if you work for an airline like Delta or KLM, can you execute the same research, or?
To my best of knowledge, they do have research and development departments that they do these things, and they are looking forward. But then it's not to the extent that we do it. And of course, at the end of the day, they are business, so they need to make money out of it. So the business model at the end of the day, it's different.
Mm-hmm.
So I agree a lot with Roger. Our business model is to create knowledge at the end of the day, and to try to disseminate it across.
Yeah. What is something that is today feels like the future, but in 10 years or 20 years is on an aircraft in your field of research?
I would say the concept of structural health monitoring. I think it will be in 10 years we will fly with that, meaning that we are gonna monitor the primary structures, so the ones that they do carry the loads, and they keep the aircraft as one part. They will have sensors installed permanently. They will monitor its condition, and we are gonna, via the data analytics that we're gonna do, in a combination, of course, always with the classical engineers, to decide on when and how maintenance needs to take. So for me, this transition that I also said before, from the schedule-based maintenance towards a condition-based maintenance, I think the next 10 years will happen to a high degree.
And is there a different field of industry where the condition-based maintenance is already happening?
It's happening also already in aerospace, in civil aviation, but not for critical safety components like structures. So it is happening, for instance, for the air conditioning.
Okay.
They do that. The engines are quite advanced in sensors. So they do that a lot of it. So they're collecting data. They are making analysis of the state of the performance. Engines also the performance. Now, if I go to different industries, from my knowledge, is on infrastructure. So bridges, including the foundations of wind energy. So the plants. Wind energy also. They are going towards that.
And do we learn from them, or do they learn from us?
Both.
We are in contact with these wind energy researchers.
We have a lot of projects on wind energy in our department.
Is it true to say that we can test it on a wind turbine, and if it works, we can scale it up towards an aircraft? Or
maybe it's a good time for me to jump in and say, wind energy is one of the topics in the Faculty of Aerospace Engineering. We have there's a research group working dedicated to this topic, and as I'm in the faculty, I also get involved with this structural health monitoring for wind energy. I'm working in a national project currently called AirTub Romy, where we're installing different types of structural health monitoring sensors into real wind turbines. So we have them installed in two wind turbines in the south of the Netherlands. The types of technology of the sensor, we're using acoustic sensors. We're also using fiber optic sensors, and we're using lightning strike sensors.
Okay.
So the acoustic sensors listen for impacts or noise or cracking sounds. We're also looking at the vibrations with the fiber optic sensors. And I would say also the lightning strike is a very big problem for wind turbines. So having lightning strike sensor is important, and also combining the data from all of these three sensors. And we're sharing knowledge between the aviation and the wind energy, and we also meet the colleagues from other faculties, and we also meet them at conferences. So colleagues working in things like civil engineering and bridges. But I would say the civil engineering looks to be a little bit more advanced in having the sensors installed. But we have a much more complex structures in aerospace. So we have a bit more of a challenge to measure, record the data, and also to interpret the data.
So that's what I'm trying to ask, because I heard a lot of, let's say, data collection. Also, Dimitrios, in your example with the Delta Airlines, there's a lot of data coming in. You have to make an interpretation of the data to make a solution or make a decision, I would say. Sounds to me AI. What do you think?
Yes and no. AI nowadays is it's a buzzword. That can be, everything can be AI and everything cannot be AI.
What is your opinion? What is your standpoint?
My standpoint is
researcher?
that the concept of AI, at least in the way that we are doing it on data, should go to machine learning.
Yeah.
So we need to have a specific task that we as engineers design, and we ask the machine learning algorithm to fulfill this task.
Yeah. And sorry to interrupt you, but what is the difference between machine learning and AI for the understanding?
Machine learning is part of AI, so it's not a difference. It's
part of.
It's part of it.
Yeah.
Definitely, for instance, from our experience, because we want the concept of health monitoring as general to be implemented.
Mm-hmm.
That's very, very, very important. Is that we need also to tackle or to address it to the regulators.
Yeah.
And AI nowadays, it's becoming a bit, or the concept of AI in general, comes with a bit of skepticism about how we are gonna verify and validate that. So it needs to come always with next to human-assisted, for instance, AI algorithms.
Yeah.
And starting from the data that we are collecting, definitely we can use the engineering, so the classical features that we know, or statistical features if you talk with the data scientists.
Mm-hmm.
That's going to be a good start.
So you mean human interaction, or I think so that means that you have the data that's being presented to a human, and that the human is making the decision what's the next step.
For instance,
Yeah.
yes, and can use machine learning algorithm in order to do interpretation, because there is a lot of research nowadays. It's still on research level, as far as I know, that
Mm-hmm.
you collect the data, you throw it to deep neural network, and you train it for a specific task, and then you don't see the data. I hope, that's my personal, that this is not going to be the case when we implement it on an aircraft.
No.
So always someone is going to be there to check what type of data, do they make sense, and then we can use the machine learning to optimize our performance, to do it faster, for instance.
I think that maybe I would disagree a little bit here. I think we need to proceed cautiously. We have to think that what we want at the end of the day is the correct decisions. So the correct decisions for maintenance, maybe also correct decisions to feedback to the pilot, or maybe correct decisions also to improve the fuel efficiency of aircraft.
Mm-hmm.
But we have a big hurdle, which is the certification of these technologies.
Yeah.
So I agree with some of the steps there that Dimitrios has outlined. What we're doing with the data at the first stage, we are just processing the data with these machine learning or AI algorithms, and just giving some sort of indication to the human to help them make the decision. So that's one step. The next step is that you sort of direct the human to problem areas within the structure. So the AI would make an assessment, and then it would say to the human, go and look at this point.
Yeah.
I think there's something wrong there.
There's a high probability that in that area.
And these are sort of steps. So we need to go up these steps one at a time, in my opinion. We will then, I think, maybe get to the point where the AI is making the decision and the human is checking it.
Yeah.
I think that's quite a reasonable way to work, as long as we have experienced humans. I worry a little bit that if the AI is doing too much of the detail of the inspection work, that the humans in the future won't have enough experience to do the check-in.
Yeah,
and then we can think about whether it's just a full AI decision and there's no human in the loop. That is maybe a little bit scary for me, but it could also mean that the decisions become better than the decisions made by the humans.
Yeah.
So it's really for us to say this is what I'm comfortable with on that scale, and what the general public is comfortable with. Are they comfortable with the AI making all the decisions, or do they want a human there in the loop,
Yeah.
making sure that the right decisions are made.
And what do you think? Does it change for the passenger if they board an aircraft that's fully controlled by AI?
Yeah, I think maybe it might be that it's a more efficient. Maybe it's a more efficient airline, so maybe they have a cheaper prices.
Yeah.
But then we don't fully know. Then the risk is we don't fully know all the engineering aspects.
Okay. So then it comes back again to the basics of engineering.
So we need to. We can say that the AI may be involved more and more in the decision making. But then we have to also say, how is the AI making these decisions?
Yeah.
And are the decisions trustworthy, and are they reliable?
And can one of you name maybe an example in a different field that this is already happening? That, let's say, the AI model outperforms the expert.
Autonomous driving, for instance.
Yeah.
Like we've seen some taxis mainly in California.
Mm-hmm.
At least from videos that I've seen around. Yeah, they are taking the decision, so there is no driver needed.
No.
What I don't know there is what is the legal. So who is the responsible if something happens? So for the decision making, for instance, the ownership of.
That's one of my questions.
And how we're gonna do the insurance?
Yeah, that's what I wrote down. Who's responsible when an algorithm makes the choice?
Yeah.
But if I listen to you, Roger?
Yeah, just with the self-driving cars, I think we're getting to the stage where the AI is able to drive better than some people, but some people are able to drive better than the AI. So that we're getting into that like a grey area where the AI is sort of approaching the performance of some of the humans.
Yeah, and do you both look at such a development?
Yes, of course.
And
we have it also in our faculty with the drones, MV Lab, for instance. So that they do the autonomous flying.
Yeah.
So we see. Yeah.
And are you in contact with these drone researchers?
Specifically, we are in contact for the prognostics of the mission accomplishment. So they have a specific mission.
Mm-hmm.
Can we accomplish this mission given the state of for drones? For instance, a very important thing is the battery.
Mm-hmm.
If there is still a lot of battery in place, how we are going to complete the mission? What is the best path to do it? So these are the concept of prognostics for operations.
Yeah.
So we work together on that.
Yeah. Maybe a different question is that how important are startups for your field towards the industry? Because we do research like low TRL, and then the industry mainly says, okay, that's really nice, Roger and Dimitrios, but first prove it, or take some steps and then come back.
So from the census point of view, I think the startups have a very important role in bringing new sensor technology to the market.
Mm-hmm.
So when we're at the university, we're developing new technology. There's also technology being developed at research institutes like TNO, for example.
Yeah.
And then I think startups are a very good way to bring that technology. They're sort of in the ecosystem between the research environment and the business environment.
Yeah.
They can bring the new technology, and they come with also a lot of enthusiasm to keep the startup running and to find the budgets, and usually very, very active people in these companies. And it helps us to sort of explore different sensor technologies. Mm-hmm. And see which ones would actually be accepted in the industry, and which ones are going to not be successful, and maybe the company is going to fail, and they will maybe the founders will restart with other technology. I think it's also the same case with the AI. There's quite a lot of small startup companies working on AI technology. Yeah. And it's a way to try things and to test them in the market, but without maybe the bureaucracy of a larger organization.
And how does it reflect if you look at the startup versus an FAA or an EASA?
Yeah, the regulatory bodies, they are there. They should be there.
Of course.
I don't think that we need to question them. That's we are working, let's say, for engineering solutions for an industry as aerospace faculty that is, I dare to say, the safest in the transportation.
Mm-hmm.
To me, I'm not aware of EASA thoughts on that, but how I see is that they also support the ideas, and so they are open to discuss with newcomers, startups, to help them, to guide them in order to make, to give them the knowledge on how they can make a product, whatever that product means, that can go to the market.
Yeah, and that going to the market, is that in an airline or is that in an aircraft manufacturer?
It can be in the ecosystem,
in the entire
chain.
Is the regulatory body part of such a project at the TU Delft, or
with startups?
No, let's say
in general. Yes.
Yeah, in general. So I know these startups are like in the ecosystem of a project, but are these?
There were several projects, especially from EU, Horizon 2020 and Horizon Europe, where especially in Europe, I'm talking about EASA, that they were parts of the advisory board.
Okay.
So for specific reasons, they cannot be beneficiaries. It's against the regulation, so they cannot get money because then they create a bias. It makes sense. But they can participate as advisory boards.
Okay. Yeah. And listen to the results.
Listen and actually advise.
Yeah.
Advise what you could do if you want, for instance, to increase the TRL. So how we are going to evaluate. So guys, look at that and look at this. So their role is quite important.
Yeah.
Yeah, I think we shouldn't forget the role of the larger aerospace companies in supporting the startups. So where companies, for example, like Airbus, if they see high potential technology at a startup, they will keep that startup close, and they will support them, and maybe they will look for funding in, for example, the European projects or sometimes in national projects. But they will also help the startup to find their way in the ecosystem with regards to the certification. Yeah. And I think for the large company, the outcome then is that they have like the world leading technology, which is what they want to have on their aircraft.
So they're pushing the scouts to help it in their ecosystem.
Yes.
Yeah. Okay. Thanks. To close off this already we're talking for almost an hour. I've prepared 3 statements, and you have to choose.
Okay.
The first statement is doing research or teaching.
Okay. I can start with the honest answer.
Yeah.
For me, earlier in my career, research was the big interest for me. But as I've developed and got more knowledge, I also want to pass my knowledge and expertise on to the younger generation. So I'm transitioning from research to education focus, but also keeping some balance between them.
Okay.
I'll give also politically correct answer. Teaching how to do research.
Okay.
So that's what I'll look into the future. Yes.
Yeah. The second statement is the technology you both work in, or the field of research, it's already there, or we need more time to do more research.
Yeah, we always need more time and more money, of course, to do more research. We're aiming to do our research at the boundary of knowledge. We're exploring all sorts of interesting things, which some of which may become very important. Some maybe will disappear or don't work. But we always need more time. It's a ever expanding knowledge.
Never ending story.
Yes.
Yeah.
Yeah, it's very similar. It's like our cosmos is expanding. Yeah. So also we are pushing the boundaries. There are technologies that I do believe can be used right away. But that doesn't mean that we need to stop research further and check if on different concepts or different studies. The knowledge creation nowadays is even more important than it used to be.
Yeah, why is that?
There is an easiness in everyone, no matter the age, to find solutions, and everyone it's getting a bit relaxed on that. Personally, I don't like this. So I always need to find a way of keep, the ball rolling.
Mm-hmm.
And to me, is that's one way of doing is that's research. So keep pushing.
Keep pushing.
Keep pushing.
Now, last question for you both is: I don't want to fly at all anymore, or fly constantly.
Second.
Yeah.
Yes. I recently came back from Milano.
Mm-hmm.
It's 1 hour and 15 minutes. It's nothing. And from Netherlands, you go to a very nice place in Italy.
Yeah.
Netherlands is also very nice. But
Yeah.
I also like driving a lot.
Yeah.
It's just relaxing, but flying, and I think it will become even more sustainable in terms of the footprint that it creates. So every part of this ecosystem in aviation, I think, puts a lot of effort.
I think so as well. Yeah.
Which is a very good news, and I think it will remain like this, and hopefully it will remain like this.
And for you, Roger?
Yeah, so this is a very big good topic to open up at the end of the at the end of the discussion. So of course, I think we are using more resources than are available on the planet. So we really should be looking to reduce our footprint. I think it's part of this is flying less. And it's a matter of just looking at the different options, which is the best way to travel. For example, if I go to Paris, it's not really even a decision. I would just take the train.
Yeah.
Whereas in the past, you could fly from Netherlands, you fly from Amsterdam to Paris.
Yeah.
So I think it's just making smart choices every time that you travel, and try not to have too much of a impact, and look for sustainable travel options.
Yeah, thanks for that. Thanks both for this podcast.
We thank you.
Yeah,
yes.
Thank you.
Nice.
Thank you. Aircraft are no longer just machines we design. They're becoming systems that observe, learn, and respond. And that changes not only how we build them, but how we trust them. Thanks for listening to Coffee with Martin, and tune in for the next episode.